there any homework assignments, or homework assignments, any homework problems that we want to go over?
What is this?
From the book pages. Any numbers? We got them all. We're 100% correct?
Yeah. No.
You're not listening. I got a timer.
Dude, this is pretty legit.
Alright, I'm going to give you the answer to that table on the bottom of the 202, is it? These are the answers for that table. Number 5 is 2, -2. I'm going to go across. So 2, -2. 2, -4. -3, -4. And -3, -2. That's across on number 5. Number 6 is 4, -3. 4, -1. -1, -1. And -1, -3. Talk about. Great. Number 2. So first, someone give me the pre-image point for number 2. What's the pre-image point of this shape right here? They give them to you, so it shouldn't be very hard.
-4, -4.
Is that S?
Yeah.
What's P?
-5, -1.
What else do we have? Q?
Q is -2, -1.
And what's R?
-1, -3.
And then what's the rule that they gave us to use? What reflection did they give us?
Switch around and make it positive.
X and -y.
Yeah, they gave us the rule where our x's stay the same, but our y's change sign. What does that mean we're reflecting over, the x or the y-axis? If our x's are staying the same, but our y's are changing, which one are we reflecting over? Yeah, the x-axis. Because when we reflect over the x-axis, our x's don't change, only our y's do. So if our x's are staying the same, what should all my x-coordinates be in those points? What should p prime's x-coordinate be? If it's not changing, what should it be? -5. What should s prime's x-coordinate be?
-4.
-4, because it's not changing. What about q prime?
-2.
What about r prime?
-1.
Yes, because our x-coordinates didn't change. But our y-coordinates are changing. So what should our y-coordinates be for each of those points? We just got to change the sign. So in our first point, we have -1 in the y value there for letter P. If it's a -1 and the sign is changing, what does it become? A +1. So what should happen for the s point? What should happen to that -4? Thank you, Julianne. A +4. What about q and r? What should happen to those? What should happen to that -1 in the q? It's in that y spot. It's changing signs. What happens to it? Yeah, it goes to a +1. And what about in r? What happens to that -3? Yeah, I hear it multiple places. +3. So those should be our image points. When you plot the image points, you get that picture. So and if you look at your card that we made, that should make sense. If we plugged in those points, it should match up with our rule on our card that we have. Does everyone still have their card? Good, good. Any other questions on the homework before we move on? Make sure we have a good understanding of how to rotate and reflect and to translate, because next week we're going to do combined ones, and we really make sure we can do them individually. So if you're still having trouble, come get help at lunch or after school, and we can work through some more of these problems if you're still having trouble applying those rules. Okay? We understand? Thumbs up? Understand? Thumbs up? So, yes. All right, good. Let's open up to to page 205. What does it mean for a shape to be congruent? Yeah, Haley, what does it mean if it's congruent? They're the exact same. So they're the same size and they're the same shape. What does it mean for a shape to be similar? We have a similar shape or a similar figure.
Same.
It could be,
Star?
it could be the same shape but different sizes.
Yeah, similar figures are same shape or different sizes. So keep that in the back of your mind when we work through this lesson today. So everyone needs that favorite little half piece of paper that we've been working with. You don't even need a half. You could probably do like a quarter. So you can take one out and share with everyone at your table if you need to. So we're going to do some more tracing.
Good talk,
See, does everybody have some paper or do they need some paper?
I need some paper.
I got paper. No, I'm not.
Wait.
I'm saying yes, no, I'm not.
If you have your paper, Olivia, why are you cutting it?
I thought it would look beautiful.
What if we need it to be perfect?
It's perfect now.
Mine's pretty perfect. It's like a perfect rectangle.
Hold up your paper if you have a piece of paper and it's not cut yet. Do you need a piece of paper to write on? Just paper? Anybody need a piece of paper? Thank you, you can put it down.
Y'all just crazy.
You can put it down. Y'all are crazy. Snow days that made us so rowdy. This is the most energy I've seen this class have in a while.
I have to
Take your piece of paper and place it over the graph, and you just need to trace the shapes. You don't need the X and Y axis. Just trace the shapes. Just trace your shape. You say you're becoming good at tracing? You've done a lot of tracing. I don't trust myself like this. And make sure you label the vertices. I'm going to write them inside though so they don't get like cut off when we cut them. So it should look something like that. Just trace the rectangle and trace the triangle.
They're tiny.
I put the letters inside so when we cut them out in a second, that is a really big rectangle. Are you patient? I think you're tracing the wrong one. Yes, they're not very big. When we're working with the baby scissors, I apologize. Beautiful tracing. You don't need to draw the graph. You just need the shapes.
Oh.
Yes, you just need the shapes. You don't need the whole graph like you were doing before. You just need the shapes. 5 minutes. I don't have to know what to do.
Okay, we're taking your desk pieces away.
Wait, so then we just put them out?
Yes, cut them out once you trace them. Cut them out. They're small, so keep track of them.
I'm gonna end up swallowing one of these.
It's okay.
Olivia's gonna cut herself. This is why I think it's bleeding. She's intelligent.
Are you cutting them out? Place them on the graph.
They're so tiny though. It's like
Did you guys hear what I just said?
yeah, put them out, put them on the ground.
And then what?
You just said that. You gotta move them.
Place them on the ground.
Yeah, but you just said that. Or maybe USA. What did we do?
Your shape's got to be on top of the shapes that are already there.
Mine are too small. Wait, they're made in the USA.
Mine's too big.
First, made objects.
Is this good? Good. This table is good.
No, I'm
Would be a spin difference.
You know that? No. Made in China.
Good. The table up front is good.
There is billions of birds. I have like richer than the United States of America. Because everyone has so much and we have like more than in the 70s. So it's like,
Did you place yours on your graph?
no. I covered my own
They made one.
Someone here.
Star, make sure you cut that some shapes.
Triangles on the ground.
Thank you, Felicia and Lexi and Riley. Some of us still like Okay, now that our shapes are on our graph, we're going to take our rectangle and what does it say? Translate it 6 to the right, and then what? What's it say? 6 units right, and how many units down? What's it say on letter B?
What are we doing?
One
unit
yes.
down.
So translate it 6 units to the right and 1 unit down. So 1, 2, 3, 4, 5, 6, and then 1 unit down. So it should look something like this. Your A point should be at 2, -2. Once you have it translated, trace it onto your graph.
Oh.
It's stuck to my finger.
And then label it A prime, B prime, C prime, C prime. So we translated this. How could we write a rule for it if we translated it 6 to the right and 1 unit down? How can we write our rule for that? What does it look like? Star, next to the
X plus 6
Yep.
and Y minus 1.
Yes. X plus 6 and Y minus 1 is the rule that we would write for that translation. So did everyone translate the rectangle? Did you see how we got the rule?
But when you get there. Don't play him around.
I would not not even a pencil.
Now, can somebody read what letter C says? The side conversations need to stop. We are in class right now. In 2 periods, you'll have lunch. Then you can be more social. I know the 2 snow days interfere a little bit, but we got to get through this lesson so we can move on to some fun stuff.
Fun
Some
stuff.
really fun stuff. I think
I do math.
It does. But first, someone read letter C. Thank you.
Once you're happy of the triangle on top of the triangle equals, then translate the triangle by sliding the top and 5 units to the left and 2 units up. Draw the new location of the triangle on the coordinate plane and measure the vertices of 3 times 2 times and R times.
So how are we translating this triangle? How many units left or right and how many up and down? What's that, Bailey? Say it louder.
5 left and 2 units up.
5 left and 2 units up. So move your triangle 5 to the left. So 1, 2, 3, 4, 5, and then 2 up. So your P point should be at, it looks like 1, 2, 3, 4, negative 4, 3. Oops, I didn't do that wrong. So your P point should now be at negative 4, 3, if you translated it correctly. And then trace that triangle onto your graph just like we did the rectangle. And then label it P prime, Q prime, and R prime. And then you can move your shapes off to the side.
No.
Anyone else have trouble? They were sticking to my fingers. Yeah. Marcus, can you read what letter D says?
Maybe.
Marcus, can you read letter D for us? We don't really have a ruler, but we can count those blocks. But what's it asking us? What's the question it's asking us right there at the end of part D?
Use your ruler to measure the line segment AD and PR. Then measure AD prime and PR prime. What do you notice?
We don't have to get a whole bunch of rulers out to notice what they want us to notice. Because we also know that we can use the grid to look at side lengths. So if we look at AC, side AB, how many parts of our grid, how many squares make up that side?
2.
Yes, 2. If we look at the A prime and the D prime, how many make up that side? 2. If we look back at our triangle and we look at PQ on our original triangle, how many make up that base? Yes, 3. And what about over here? On our image, 3. So what can we say about side lengths when an image gets translated? What happens to them?
They're still the same.
Yeah, they stay the same or they don't change. And that's what you want to put on part B. I'm going to put translations don't affect or do not affect or do not change. You can put side lengths or line segments if you would like. Either one. So I put that the translations do not change the length of sides, and they don't change, or you could put line segments as well. You could have the length of the side or line segment, same thing, whatever one you like better. If we look at the angles, Destiny, if you look at the angles of your image and your pre-images, what do you notice?
I know.
There's right angles in both of them? There are, yes, there are right angles in both of them. What else do we notice about the angles? Did they get smaller? Did they get bigger? Did they go from like obtuse to acute? Did they change?
No.
No, they're the same. Yeah, you're right. So what are we going to put for part E? Yes, they're congruent. They stay the same. I like congruent.
I like it.
So we're going to put translation. Do not change angle measures. Sorry, I told you. Translations do not change. That's a theme. I put it out. Angle measures. So our angles stay the same. They're congruent. I like that word. And then what about like the parallel lines? If we look at the parallel lines on our rectangle, did those change at all? Did they change the way they were facing? Are they still going the same way? We still have 2 vertical ones and 2 horizontal ones. We still have A, B, and A prime, B prime. It's all facing the same way. Yes, no? Yeah, so what should we put for part F? Yeah, the translations don't change orientation of our segments. So translations do not change the orientation of segments. Do we know what orientation means? So the way I'm oriented right that wall with the shapes. If I was to rotate, I'd be looking at the back wall here with the posters on it, and my orientation changed. I'm not looking at the same wall anymore. But when we translate, I'm looking at that wall with the shapes, and if I translate myself left and then like down, or well, I guess that was right enough for you guys, I'm still facing the same way, right? So my orientation didn't change. That's what part F was trying to get us to see. That it's not rotating or not. So what can we say for the reflect one? What's our conjecture we can make about translation? They don't change orientation, we know that. They don't change size, and they don't change shape. So they're the exact same size, they're the exact same shape. So what are they? You want to go write that up there for me? You're right. So Bailey. Yeah, you can put that. You can put congruent figures. That we get congruent figures. Do we see how we get congruent figures? We translated that rectangle, and it's the exact same rectangle. Congruent what? Figures. What? So we get congruent figures. Good. Beautiful.
Oh my god. Really, guys?
We're also going to use this new word that we haven't used called preserve. You might have used it in other ways. What can preserve mean? Yeah, keep something for a long time. I like that. So we're going to use the word preserve, and we're going to say that translation preserve size and shape. So when we translate a figure, its image is congruent to its preimage, and the translation therefore is preserving that size and shape. It's keeping the size and shape the same. It's keeping it for a long, long time like that. So we have questions on this page 205. So do translations give us congruent or similar figures? Congruent, yes. Was that sure? We just wrote it down. Alright, let's turn our pages and do some more tracing. You now need to trace these images, give them their vertices, give them those letters, just like we did before. Trace them, cut them out, put them on the graph. Okay. I will be doing it up here along with you. So you should trace them like this and cut them out. So Matt is going to demonstrate. Let's watch up here so you know what to do. Matt's going to demonstrate reflecting our rectangle across the x-axis. So can you flip it across the x-axis for me? You got to flip it over. It's hard to pick up. Then once you pick it up, it's more complicated. There you go. Now reflect it across that x-axis for us. You're going to flip it across the x-axis.
Freaking piece of paper needs to stay.
Yes, the x-axis is our horizontal one. Good, perfect. It should look just like that. So we shouldn't be able to see our letters anymore because it flipped over the x-axis. So once you do that, trace this rectangle into the grid. Trace the rectangle. Trace the rectangle into the grid. You should notice when you label your points, they're kind of switched around now. you should have A prime and B prime at the bottom. So can you label my bottom ones A prime and B prime?
No.
And your top ones, well you have that one C, that's B prime. Yep, B prime is the one on the right, A, and then your top ones should be D and C, or D prime and C prime. So that's what your rectangle should now look like in your book. What rule do we use to reflect across the x-axis? What's the rule? Yes. Haley said we use the one where the x's stay the same and the y has that negative on it. That's our rule for the reflecting across the x-axis. Now, Matt, can you reflect the triangle across the y-axis? That's our vertical axis. Reflect it across the vertical one. Yep. The y-axis, reflect our triangle.
Did I do that right?
Reflect the triangle across the y-axis.
They're all so small.
I know, they're so small.
One.
You should tell them to give us a big page of graphs.
Exactly.
No.
Oh no.
No?
Yes.
Marcus, good. Oh. It's okay, I had trouble last hour getting them to reflect. So it should be on what coordinate? What coordinate should the triangle be in? Or sorry, what quadrant should it be in? Third one. It's in which quadrant? Marcus says 2. Matt says 2. It goes 1, 2, 3, 4. So it's in 2. It goes 1, 2, 3, 4. It goes like counterclockwise.
Wait.
So it should end up in quadrant 2. So yours should look like how Matt's is here. Oh, put it up a little bit.
Don't
It's
judge
right
my
here.
cupcake.
Trace that into your graph. So yep, it's flipped around.
Where do we put the triangle? Oh,
Hey, how do you know where to put the triangle? Let me see. Can you see how you reflected it? No.
Matt.
Good, because that's across the x-axis. We're going across the y-axis. Yes, we're going across the y-axis, not the x-axis. Only this part. Oh, this part's right. So Marcus is answering part D for us up on the board. So they stay the same. So reflections do not change the length of the line segments or the sides. So it's pretty much exactly what we had on our last page. Just instead of translations, we have reflections. So you need to have that reflections. They stay the same, the side lengths stay the same. Yep. Or you can put that the side lengths don't change. You can put reflections don't change the side lengths. There's a couple different ways we can phrase it. Yep. Alyssa's gonna put E on the board for us. This is our angle measures. What did we notice about our angle measures? Did those change? No. No, those didn't change either. So we should have something like we had on our first page where reflections don't change angle measures. Or angle measures stay the same. Yes, put the scissors down. Yes, they're congruent. I like the word congruent. And what about parallel lines? Did our parallel lines change this time?
No.
No, so again, we're just going to put that the reflections don't change our parallel lines. So then what do we put for our conjecture on 2A? Think about that one for a moment.
What did we put last time?
Think about reflect 2A. What can our conjecture be? What did we write on our conjecture on the first page? On, what was it, 205? Yeah, we had congruent. What else did we have?
Same size.
Yeah, so we put the same thing for reflection.
all
We're
right.
going to put that word preserve again. Reflections preserve size and shape. And then we get that congruent figure. reflected figure, its image and pre-image, are the exact same. It might have a little bit different orientation this time. It might be facing a different way, but it's still the same shape. Let's look at a rotation. So Andrew, stand up, please. Andrew's going to be our rotation. Andrew, rotate yourself 180 degrees from where you are now. So Andrew rotated 180 degrees. Did the length of Andrew change at all? Did his size change? Did his shape change?
His arms are moving.
So what can we write about our rotations? Yeah, we're going to write like the same thing. Thank you, Andrew. We're going to write that we get a congruent figure and that our line segments and our angles all stay the same. So some things you should have for our try this 2B. We'll have rotations. I'm going to use this word map. Say map line segment to line segment. And now all that means is that we get congruent line segments when we do a rotation. That means they're not changing. We're getting this exact same line through our rotation. So I'm going to put of equal length. That way we know those things. And then we're also going to put angles to angles of equal measure. And then what do I put for what do they preserve? What should I put for that preserved part? Yep, it preserves shape and what else?
Shape.
What's that? I heard size and what else? Shape. So do we get a congruent figure when we rotate? Yeah, we get some congruent. So again, what all that map means when it says map line segment to line segment, that means we're just getting congruent segments when we put a figure through the rotation. The rotation is mapping one segment to the same segment in the rotation. So what kind of transformations give us congruent figures? What type of transformations give us congruent figures? So we have 4 transformations. We only talked about 3 today. Which ones give us congruent figures? And what are those? Ariana? So rotations, translations, and reflections give us congruent figures. What transformation gives us a similar figure? The one we didn't talk about today. Yes, a dilation. But we talked about those a lot last chapter and a little bit at the beginning of this chapter. Dilations are the ones that give us similar figures. So just keep that in mind, that the 3 of them give us congruent, and 1 of them gives us a similar figure. Well, in your homework, 1 of them is a dilation, because it's reviewing what we talked about before. So, let's get our agendas out, please.
I just said the algebra came out in.
I hope.
I'm not taking your sign up because I'm
I didn't do my work. How is that being lazy? I'm like rushing this.
You should have did it earlier.
That was like 2 months ago.
Make
Stupid I have to do
sure,
it. It's stupid I have to do it.
eyes up on the board, please. Copy this down into your agenda. Make sure you throw that paper away when you leave as well. Why? I don't want it. Check yourself. Well, you're not yourself.
I want to go in my binder.
Well, you can keep the paper in your binder. I meant the ones on your table.
What's the date today?
Yeah.
This is Friday the 14th. It's Pi Day.
Friday the 14th. Friday the Marcus, you have problems.
Well, I didn't say
Lesson 5-7, we talked about similarity and congruence in our transformations. We talked about which transformations give us similar figures and which ones give us congruent figures. Your homework is page 207 and 208. On page 207, you need to look at those coordinates and try to figure out what type of transformation it is. I would use my note card on that one. You need to say if it's congruent or similar. And then and what's being preserved. So definitely look back at your notes to do that first page on 207. Does anyone want graph paper to graph the points to help them visualize? I like vision.
Can we do one
Are you
together?
kidding me? You had written
Yes,
graph
we can do one
paper.
together. When I see and hear that you're ready to go, I will dismiss